Good morning and welcome to today's class. Today's class is a continuation of our previous classes on number-based system. At the last class, we were able to deal precisely with the division operation of numbers in different number bases, where I did show you how to solve problems on division. I gave you two methods that you can either do the long division method directly in that particular base, of which prior to this you ought to have learned how to get the multiplication tables in the different bases. Without that knowledge, you can't deal precisely with the first method. Thereby, that led us to the second method, which happens to be the easiest and is recommended for every student to know, which says you convert that particular number which you have to divide from that particular base to base 10, which you already know, do the division in base 10 and convert your answer back to the required base. At the end of that class, I was able to give an assignment which we are going to do, which I would like us to look at before we go over to today's class. The assignment says we should convert 2/5 in base 10 to decimals to 6 decimal place. I'm going to use both methods in solving this. The first method is the first thing to do is to convert 2/5, which is a proper fraction, to a decimal fraction, and thereafter find its equivalent in base 2, because we are asked to convert it to decimals. So 2/5 is equal to 0.4 in decimal. Okay, thereafter we have to convert 0.4 to its equivalent in base 2. And how do we do that? Is by using repeated multiplication. That is 0.4 to decimals, which is in base 2, and we are asked to do that to at least 6 BP. So 0.4 times 2 is said to be 0.8. Okay, I'll take the 0 out. Multiply 0.8 by 2. You always take the whole number part to the other side of the divide. 0.8 times 2 is said to be 1.6. Why the 1 goes to that side? I'll also multiply 0.6 by 2. That gives me 1.2. So this becomes 1.2 multiplied by 2 again. It gives me 0.4. That is 0.4. It becomes 0.4 multiplied by 2. This gives me 0.8. 0.8. Now if you look at it, we have a recurring decimal, but we were told to find its equivalent to the 6th BP. We have already done that to 5. So you multiply it by 2 again. This gives us 1.6, and it continues in that way. So therefore, our equivalence of 0.4 is said to be equivalent to 0.11001 in base 2. So this is its equivalent in base 2. I told you I'm going to use two different methods. The second method, which you can use in converting 0.4 to decimal, which is also said to be 2/5, is to convert 2 to base 2. 2 in base 2 is said to be 10, while 5 to base 2 is said to be 101. So using the long division method, this goes into the square root sign. So this is 101 divided by 10. Okay, just like I said in the previous class. 101 into 10 cannot, because this is 5 and this is 2. So I'm going to put a decimal, put a 0 and a point, and add a 0 to this. 101 into 100 cannot, because why this is 5 in base 10, this is 4. So I'm going to add a 0 and add another 0. So 101 into 1000 will go one time, because this now becomes 8, and 8 is greater than 5. So 1 times 101 is said to be 101. Do find the difference. This becomes 0 cannot, you cannot subtract 1 from 0. So this becomes 0. This becomes 2. It loses 1. This becomes 1. This becomes 2. It loses 1 again. This becomes 1. And this becomes what? 2. So 2 minus 1 is 1. 1 minus 0 is 1. And 1 minus 1 is 0. Why this is also 0. Now that brings us back to this. 101 into 11 cannot. Okay, so what do you do? Because this is 5, while this is 3. You add 0. Okay, so this becomes 5. Why this still remains is 6. So this is 6. 5 can go into 6 one time. 1 times this, it will give you 101. Subtract. This becomes 0. Why this is 2. So 2 plus 0 is 2, minus 1 is 1. 0 minus 0 is 0, and 1 minus 1 is 0. Add another 0. 101 into 11, it cannot. So as you add another 0 to this and a 0 up there. This now becomes 101 divided by 100. 101 is 5. While 100 is 4. It cannot divide still. So you add another 0 down here as well as another 0 up here. And you see if it can divide. Now this becomes 101, which is 5, divided by 1000, which is 8. It can now divide. And it will go one time. 1 times 101 is 101. That brings us back to the first step there. You subtract again, and this is 0, 1 plus, 1 plus, and 2 plus. 2 plus 0 is 2, minus 1 is 1. 1 minus 0 is 1. 0, 1 minus 1 is 0, and 0. So you add another 0. Okay, remember the question says we should walk to the 6th decimal place. So at this point, you are required to stop. So 10 divided by 101 is said to be equivalent to 0.01101 base 2. And if you look at the first method that I used, it was the same thing that we got. So any of the two methods will still give you the same answer. Compare my answer with yours, and if there's anything you don't understand, you can use the comment section to ask us questions, and I'll definitely be there to attend to your questions. So let's go to today's class. Today's class, we shall be looking at the 5th objective, which says we should solve equations involving number-based systems. Today's class, we shall be looking at the 5th objective, which says solve equations involving number-based systems. We have gained enough knowledge on equations on number-based systems other than base 10, of which at the previous class or classes, I introduced the number-based systems, the different number-based systems that we have, how to convert from one number-based system to the other, how to convert from base 10 to other bases, and how to convert from other bases to base 10. So after being equipped with this knowledge, we should be able to use our knowledge to solve equations involving number-based system. And we have some examples here which we shall be dealing with. Example 1 says, given that 13 base x is equal to 12 base 10, we should find the value of x. We don't know the base, and it's said to be x. 13 in what base is equivalent to 12 in base 10? That is the answer. That is the question. So what we have to do in this case is to, first of all, convert 13 from base x to base 10, which we already know how to do. And once you're able to do that, you'll be able to solve. It becomes a linear equation or a quadratic equation, as the case may be, and you solve it to find your value of x. So solution: 13 base x is equal to 12 base 10. Since they are in different bases, I won't be able to solve. Using the expanded method, I'm going to convert 13 base x to base 10. This becomes 1 times x raised to power 1 plus 3 times x raised to power 0 being equal to 12. 12 is already in base 10. Okay, so this now becomes 1 times x raised to power 1 is said to be x plus 3 times x raised to power 0 is said to be 1. For anything raised to power 0 is 1. So 1 times 3 is said to be 3 is equal to 12. So that this now becomes a linear equation, and we'll then solve by collecting like terms. When you subtract 3 from both sides, this becomes x plus 3 minus 3 is equal to 12 minus 3. So that what we have on the left hand side is x, because plus 3 minus 3 is 0, is equal to 12 minus 3 on the right hand side is 9. So definitely our x is said to be 9, meaning 13 base 9 is equivalent to 12 in base 10. That is your answer. Question 2 says we should find x given that 123 base x is equal to 27 base 10. We'll still take the same step like that which we took in the first example by converting 123 base x to base 10 and then solve the required equation. So this now becomes 123 base x is equal to 27. This has the place values of 0, 1, and 2. Using the expanded method, this becomes 1 times x raised to power 2 plus 2 times x raised to power 1 plus 3 times x raised to power 0 being equal to 27. So therefore, x raised to power 2 is x squared times 1 is x squared plus x raised to power 1 is x times 2 becomes 2x plus x raised to power 0 is 1. 1 times 3 is 3 is equal to what? 27. Simplify further, this becomes x squared plus 2x plus 3 minus 27 is equal to 0. That is, when you subtract 27 from both sides, this is what you will get. Simplifying further by collecting like terms, this becomes x squared plus 2x minus 24 is equal to 0, because plus 3 minus 24 is said minus 27 gives you 20 minus 24. Now, this is said to be a quadratic equation. From our previous classes in GSS 3, where we're treating algebra, I told you that a quadratic equation is that in which the highest power of its variable or the unknown is said to be 2. And of this equation, the highest power of x is said to be 2. So this becomes a quadratic equation. And in solving a quadratic equation, we said we'll use the factorization method. Where we cannot use the factorization method, then we introduce other methods such as the completing the square method, the formula method, or the graphical method. But let's see if the completing the square method or the factorization method will work. Now, for us to factorize this, you discover that there's nothing that is common in it being a 3-term expression or equation. So in order for us to factorize it, we are going to first of all convert it from a 3-term equation to a 4-term equation. And how do we do that? Or how can we do that? You multiply, you look for 2 terms that when you multiply the first term and the last term, it gives you those two. When you multiply those 2 terms, it gives you the product of the first term and the last term. And when you add those 2 terms together, it gives you the middle term. So what are those 2 numbers and how can we get them? Now the product of the first term and the last term is said to be, the first term is x squared and the last term is minus 24. So when you multiply both of them together, you will get minus 24x squared. So you have to look for 2 terms that when you multiply them together, it gives you minus 24x squared. And when you add them together, it gives you the middle term, which is plus 2x. So what are those 2 terms? In order for you to get those 2 terms, look for all the 2 numbers that when you multiply them together, it gives you minus 24. So they are said to be 6 times 4 will give you 24. 2 times 12 will give you 24. Including 24 times 1 will give you 24. And 8 times 3. Now, these 2 numbers, let's assign their signs. Let this be negative and this be positive. Now, of these 4 numbers, only one will meet the requirement, and that number is the one we are going to make use of. So, when you multiply any of these numbers, you are going to have minus 24. But let's see which of them will meet the second criteria, which says when you add them together, it gives you the middle term. And the middle term is plus 2x. If you add minus 6 plus 4, minus 6 plus 4 is going to give you minus 2. And not 2, we are looking for plus 2. While if you add this, minus 2 plus 12 will give you plus 10. Far from it. If you add minus 24 plus 1, it gives you minus 23. Far from it. Minus 8 plus 3 gives you minus 5. Far from it. So let's change the signs. Let these first ones now become positive and the last ones becomes negative, and see if it will give us. Plus 6 minus 4 will give you plus 2x. Okay? While plus 2 minus 12 will give you minus 10. While this is said to be plus 23x, and this will give us plus 5x. So of all this, you discover that plus 6 and minus 4 will give us, will meet these 2 conditions. Of these 4 sets of numbers that we tried, it is only plus 6x and minus 4x that gave us, that met these 2 conditions. So having gotten those 2 terms, what we are going to do is to substitute it with the middle term. That is, we are going to replace it with plus 2x in our expression. That becomes x squared plus, so instead of writing plus 2x, I'm going to write plus 6x minus 4x, then minus 24 is equal to 0. So we have, by doing this, we have been able to convert it from a 4-term expression to, from a 3-term expression to a 4-term expression, thereby making it very simple for us to factorize. I will now factorize them in 2s. If you look at the first 2 terms, x is common, so I'm going to factorize out x into brackets. When you factorize out x from x squared, you'll be left with x plus, factorize out x from plus 6x, you'll be left with plus 6. This becomes, looking at the next 2 terms, minus 4x and minus 24, you see that minus 4 is common to both terms, and you'll be left with x plus 6 being equal to 0. So I have been able to factorize it from a 4-term expression to a 2-term expression, but something is still common between the two terms, this term and this term. So what is common? You agree with me that what is in the bracket is common. That is, x plus 6 is common in both terms. Factorize it out again. This becomes x plus 6 into bracket. When you factorize out x plus 6 from the first term, you'll be left with x. Factorize out x plus 6 from the second term, you'll be left with minus 4 is equal to 0. Now, in algebra, when you multiply two terms together to give you 0, it is either one of them is equal to 0, because it is only when you multiply a number by 0 that returns 0 as the answer. That means that it is either x plus 6 is equal to 0 or x minus 4 is equal to 0. Now, if x plus 6 is equal to 0, what is x? Subtract 6 from both sides. This becomes x is equal to minus 6, or do same to the second equation, or x is equal to what? Plus 4. Now, we've had our answers to be x is equal to minus 6 or plus 4. But we are solving a binary equation. And in binary, there's no negative base. So we say that since x cannot be negative, since x cannot be negative, it therefore means that x is equal to 4. That is, that base is equal to 4. That means that it is only in base 4 that 1, 2, 3 is equal to 27. And if you check, you discover that it is correct. By either converting base 10 and 27 base 10 to base 4, or converting 1 to 3 in base 4 to base 10, and that gives you your answer. Let's look at another question. Question 3 says, given that 543 base n is equal to 244 base n plus 255 base n, find the value of n. Okay, same thing we did in the first two examples is what we are going to do in this next example. So what we are going to do is to convert from base n to base 10, which becomes simpler for us to solve getting our value for n. So this will take the place values of 0, 1, 2, while this is 0, 1, 2, 0, 1, 2. So expressing this in base 10, this becomes 5 times n raised to power 2 plus 4 times n raised to power 1 plus 3 times n raised to power 0 being equal to 2 times n raised to power 2 plus 4 times n raised to power 1 plus 4 times n raised to power 0 plus 2 times n raised to power 2 plus 5 times n raised to power 1 plus 5 times n raised to power 0. So we are going to simplify this further. This becomes 5 times n raised to power 2 is n squared times 5 will give us 5n squared plus n raised to power 1 is n raised to power 1 times 4 is 4n plus n raised to power 0 is 1 times 3 is 3 being equal to n squared times 2 becomes 2n squared plus n raised to power 1 is n times 4 gives us 4n plus n raised to power 0 is 1 times 4 is 4 plus n squared times 2 2n squared plus n raised to power 1 is n times 5 becomes 5n plus n raised to the power 0 is 1 times 5 is 5. Simplify further by collecting like terms. This becomes 5n squared plus 4n plus 3 being equal to, we have 2n squared plus 2n squared, which are like terms. This becomes 4n squared plus 4n plus 5n becomes 9n plus 4 plus 5 is 9. Simplify further, now move all of them to the left hand side. This becomes 5n squared, I'll rearrange as I move them, minus 4n squared plus 4n minus 9n plus 3 minus 9. So let's simplify. 5n squared minus 4n squared is said to be n squared, plus 4n minus 9n is said to be minus 5n, plus 3 minus 9 is minus 6, being equal to 0. Now, this has given us also a quadratic equation. Now, I'm not going to waste time on explaining this. I'll just go straight ahead to solve. So we are going to look for two terms. Now, when you multiply them together, it gives you the product of the first term and the last term. And when you add them together, it gives you the middle term. So when you multiply minus 6 and n squared together, you have minus 6n squared. So what are those two terms? That when you multiply them together, it gives you minus 5 and minus 6n squared. And when you add them together, it gives you minus 5n. That should be minus 6 plus 1. Let's see. Minus 6n and plus 1n. Now, when you add them together, it gives you minus 5. And when you multiply them together, it gives you minus 6. So substitute them with the middle term, which is minus 5n. This becomes n squared plus n minus 6n minus 6 is equal to 0. Now, in writing the two terms, in substituting the two terms, you can bring one before the other. There is no rule in arranging them. We can now factorize. N squared plus n, what is common? N is common, so this becomes n into bracket n plus 1 minus 6n minus 6, what is common? We have minus 6 being common, into bracket n plus 1 is equal to 0. Now, it has been factorized from a 4-term expression to a 2-term expression, and you agree with me that what you have in the bracket is common, which is minus n plus 1 is common. So factorize it out again. This becomes n plus 1 into bracket n minus 6 being equal to 0. So if n plus 1 times n minus 6 is equal to 0, it is either n plus 1 is equal to 0 or n minus 6 is equal to 0. Therefore, n is equal to minus 1 or n is equal to plus 6. But just like we said, n cannot be negative because we are dealing with number-based system, and a base system cannot be negative. So we said since n cannot be negative, so therefore n is equal to 6. So it is only in base 6 that this can happen. And I agree with that in the sense that in base 6, digits in base 6 are digits of 0s, 1, 2, 3, 4, and 5. And if you look at the numbers, there is no digit greater than 6 or equal to 6 that is here. And that informs you that that is your answer. Next, says, given that 13 base x plus 22 base y is equal to 16 base 10, and 32 base x plus 12 base y is equal to 22 base 10, we should find the values of x and y. What we have to do in this equation is same thing, similar to what we have done. I'm going to express the first equation in base 10 to have my two equations in terms of x and y. Do same to equation 2 and arrive at the same thing. Thereafter, you are going to see that we'll end up getting a simultaneous equation. Then we'll solve them simultaneously using either substitution method or elimination method to get our values for x and y. So we move straight ahead. This is 13 base x plus 22 base y being equal to 16 base 10. So I'm going to convert them to base 10. This becomes 1 times n raised to the x raised to the power of 1 plus 3 times x raised to the power of 0 plus 2 times y raised to the power of 1 plus 2 times y raised to the power of 0 being equal to 16. That is for equation 1. After solving for equation 1, we also solve for equation 2. So this becomes x plus, this is 3 plus, this becomes 2y plus 2 is equal to 16. Immediately, I'll collect like terms, move all the constants to the right hand side, while the left hand side carries only the variables. So this becomes x plus 2y plus 5 is equals to 16. This is x plus 2y is equal to 16 minus 5. That is x plus 2y is equal to 11. Call this equation 1. Go back and pick equation 2 and do same, which says 32x plus 12y is equal to 22 base 10. So we are also going to convert them to base 10. This becomes 3 times x raised to power 1 plus 2 times x raised to power 0 plus 1 times y raised to power 1 plus 2 times y raised to the power 0 being equal to 22. So simplify for that, this becomes 3x plus 2 plus y plus 2 is equal to 22. This becomes 3x plus y plus 4 is equal to 22. And this is 3x plus y is equal to 22 minus 4. This is 3x plus y being equal to 18. Call this equation 2. So we have gotten our two equations in terms of x and y. We are going to solve them simultaneously. So let me bring that equation 1, which is x plus 2y is equal to 11. So we have x plus 2y is equal to 11, equation 1. Now we are going to solve them simultaneously. Whichever method you know that is best to you, you can use it and solve. But I'm going to use the elimination method. I'm going to use the elimination method in solving the simultaneous equation. And in the elimination method, the rule says that for you to eliminate either x or y, you must ensure that the coefficient of x in equation 1 is equal to the coefficient of x in equation 2. Or same with y, whichever you want to eliminate. So, and how do we make them equal? If I'm to eliminate x, okay, I'm going to eliminate x. For us to eliminate x, we are going to multiply equation 1 by the coefficient of x in equation 2 and multiply equation 2 by the coefficient of x in equation 1. But since the coefficient of x in equation 2 is 1, when I use 1 to multiply everything in equation 1, I'll see arrive at the same answer. So I'm just going to multiply equation 2 by 3, which is the coefficient of x in equation 1. Then I'll add both of them together. Our new equation 1 now becomes 3x plus 6y is equal to 11. While equation 2 still remains 3x plus y is equal to 18. Sorry, I didn't multiply the last digit. So this is said to be 33 because 3 times 11 is 33. So we now have a new equation. Let me call this equation. Still remains equation 1 and equation 2. So you can now eliminate by either adding or subtracting. So I'm going to subtract equation 2 from equation 1. That is 3x minus 3x is 0. 6y minus 1y is said to be 5y. Y 33 minus 18 will give us 15. So we now have an equation in one term by eliminating x. So what is y? Y now becomes 15 divided by 5 and y is equal to 3. Now we have gotten our value for y. You can now substitute 3 for y in any of the equations, be it equation 1 or equation 2, be it the old equation or the new equation, whichever equation you want to substitute it into, it's going to give you, you're going to arrive at the answer. So I'm going to substitute 3 for y in equation 2. And equation 2 says 3x plus y is equal to 18. So wherever I see y, I'm going to write 3. This becomes 3x plus 3 is equal to 18. Collect like terms and make x the subject of the formula. 3x is equal to 18 minus 3. 3x is equal to 15. What is x? Divide both sides by 3. Our x is said to be equal to 5. So that means that x is equal to 5. Y is equal to 3. What that means is this is said to be in base 3 and base 5. That is 13 base x is 5. 13 base 5 plus 22 base 3 is equal to 16 base 10, and 32 base 5 plus 12 base y is equal to 22 base 10. You can follow up our lessons on simultaneous equations to see how you can prove this to show that they are both the same. This is base 3, sorry. So that is how to solve equations involving number-based system. Let's take another equation. This question says, if all the numbers are binary, you should solve the equation. What that means is, this is in base 2, base 2, base 2. They are all in base 2. We should solve the equation. What is x? What is x? If all are in base 2. So what we are going to do is, first and foremost, I don't know how to solve in base 2, or because we have an unknown. So in order for it to be for me to make it simpler, I'll first of all convert each of them to base 10, solve it in base 10, and then get our answers back in base 2. Okay? So x in base 2 is equal to x in base 10 because we don't know. So x is x divided by x plus 101 in base 2 is said to be 5 in base 10. How did I get to know that? Since this is in base 2, a quicker way to convert it from any other base to base 10, I did explain to you that you multiply the first term by 2, okay, add the second term to it, that is 1 times 2, which is 2, plus the second term, that is 2 plus 0, multiply it again by 2, which is 4, plus the last term, which is 1, that is 5. So that is a quicker way of converting from other bases to base 10. So this becomes x divided by x plus 5 being equal to 110. 110 is said to be, this is times 2, which is 2 plus 1 is 3 times 2, which is 6 plus 0 is 6. So this becomes 6 divided by 1000 in base 2 is equivalent to 8. That is, this times 2, 1 times 2 is 2, plus 0 is 2, times 2 is 4, plus 0 is 4, times 2 is 8. So I have ended up converting them all to base 10. I can now solve the equation and get my value for x. Remember, x is now in base 10. The answer I will get, I'll have to convert it back to base 2. So when you cross multiply, this becomes 8x being equal to 6 into bracket x plus 5. So that 8x is equal to 6 times x is 6x plus 30. Collect like terms, this becomes 8x minus 6x being equal to 30. And 8x minus 6x is 2x. So 2x is equal to 30. What is x? Divide both sides by 2. X is equal to what? 15. So I've gotten my x to be equal to 15. 15 in base 10. I will now convert it from base 10 to base 2, which I did tell you. So 15 divided by 2, this becomes 7 remainder 1. 2 into 7 is 3 remainder 1. 2 into 3 is 1 remainder 1. 2 into 1 is 0 remainder 1. So that 15 base 10 is equivalent to 1111 in base 2. So what that means is that this equation is said to be 1111 divided by 1111 plus 101. That will be equal to 110 divided by 1000. So this is the equation, and that is our value for x. Let's look at another interesting question. That we should find the base of the operation 4 plus 6 is equal to 20. That in what base will you add 4 plus 6 to give you 20? We don't know. So I'll say let the base be x by putting this x or n, whichever the case may be. Then I'll convert it to base 10 and then solve my answer to get the value of x. That will give me the base in which such operation can be carried out. So this becomes 4 in base x. This becomes 4 times x raised to the power of 0 plus 6 times x raised to the power of 0 being equal to 2 times x raised to the power of 1 plus 0 times x raised to the power of 0. This is said to be 4 plus 6 is equal to 2x plus 0. This becomes 10 being equal to 2x. X now becomes 10 over 2, and x is said to be equal to 5. That it is only in base 5 that this can happen. So our x is said to be 5. That brings us to the end of today's class. Before we go, let me leave you with this assignment. That if x represents a base number in the equation 315 base x minus 223 base x being equal to 72 base x, what is the value of x? I think this should be something you can try. All you are expected to do is to follow the steps I took in converting each of the numbers to base 10 by using the expanded form and collecting like terms. That gives you a quadratic equation which you can solve either by the use of formula method, factorization method, completing the square method, or graphically to get your values of x. It's going to give you two roots. of which the positive root is said to be the base. So give it a try. You can send your answers to me using the comment section, or you can send it to my mail at mylessonteacher@yahoo.com. So that brings us to the end of today's class. In today's class, we have been able to deal precisely with the fifth objective, which says solve equations involving number-based systems. Thank you very much. Do have a nice day, and thanks for being patient with us. In our next class, we shall be looking at the sixth objective, which says apply the processes of the number-based system in computer programming. Do well to subscribe to our channel. If you have not done that, you can as well like our videos, make comments using the comment section, and send the links to your friends so that they too can benefit from this project. Thank you very much, and do have a nice day.